I have two mini portable washing machines, and they are quite low quality machines that have come in for repair. Today, we will check whether they can be repaired and discuss the issues with you as well. Although there might be a difference in quality, the problems in the machines could be the same. So you can see that this machine is made of very cheap materials. First, we'll open the machine to check if the issue reported by the customer is the same as the one we find. All the screws will be removed from here. And here is where everything is installed, including its timer, which is broken. We'll open it up, and here you can see the wires tied with plastic bags, which is a bad practice because if water goes down there, it will collect in the plastic. If the wire gets cut in such a situation, it can cause a short circuit. Sometimes, small issues like this arise due to the low quality of the machine, as low quality wires are used. The switch here is also cut. Now I'll connect the switch to the board. The indicator light is on, which means electricity is reaching it, but the machine is not starting. The timer is running, but the machine itself is not starting. I'll turn off the machine now and open the timer. It seems that one of the wires, the blue wire, is broken from this point. When we connect it again to the power, it short circuits, so this will be a longer repair. For now, we'll set this machine aside and check it again later. Now, let's check this machine to see what the issue is. The drum is completely free, and there's no other switch present, just a timer and an indicator light. We'll turn it on, but the red light is not turning on, so it's unclear whether it's getting electricity or not. It's in a doubtful state. I'll turn on the timer, but the machine isn't starting, so I'll turn the timer off. I would suggest always checking the wires in such cheap machines because there's a high chance that the wires may break due to their very low quality. As you can see, the wire has come loose from below and it could break at any time. To repair this machine, we can use 2 or 3 methods. First, we can test the motor by disconnecting all its connections and checking it separately to see if it's working properly. Alternatively, we can check the machine step by step to identify which part is faulty. For this, we'll use a multimeter, as it's essential to diagnose the issue accurately. We'll start by setting the multimeter to AC voltage. Now, let's look at the main wire of the machine, which is carrying electricity. We'll remove some tape from a few points to check it. There are 2 wires. One is connected to the timer, and the other is directly attached to the motor. I'll disconnect these wires and attach one clip of the multimeter to one wire and the other clip to the other wire. Now we'll check with the multimeter to see if voltage is present. When I turned on the electricity, the multimeter showed 230 volts, which means the wire is fine and the supply is reaching the motor. We'll now turn it off again. Now, we need to test the timer, and we'll do it in its current position. Here's how it will be done. This green wire is connected to the motor's running point, so we'll check from here to see if the electricity is reaching the timer. I'll remove the tape and place the multimeter probe here to check if voltage is present. I'll turn on the timer and switch. And as soon as I supply electricity, the multimeter shows 230 volts, which means the timer is functioning properly. Now, let's return to the motor. We'll turn off the electricity and remove the probes. There are 2 approaches we can use here. You can see there's a capacitor connected, which often becomes weak. A weak capacitor cannot start the motor, so we'll remove it. This capacitor is 10 microfarads and 400 volts. We'll replace it with a new capacitor and secure the connections after installing it. With everything set, I know the wiring and timer are fine and there are no issues. Now, I'll supply electricity again to see if the motor starts with the new capacitor. However, after changing the capacitor, the motor still didn't start. Now, we'll turn off the electricity again and disconnect the capacitor from here. Then we'll use the multimeter and set it to measure ohms. The blue wire is connected to the timer, and the other main wire is the starting wire. We'll attach the probes and check. The meter isn't showing any reading, which means there's no continuity in the running or starting wire. Next, I'll connect the probe to the common point, and again, the meter shows no continuity. This indicates that the motor's internal wires are broken, or the motor itself is burnt out, which is causing this problem. Now, to remove the motor from this machine, the first step is to work on the drum. If you look at the drum, you'll see a nut at the bottom, which will unscrew. After removing this, you'll find another nut underneath, so we'll unscrew that as well. I have unthreaded the bolt, and now I'll turn the machine upside down. You'll see 3 screws. We'll unscrew all of them. Now that all 3 bolts are removed, the challenging part begins. If the motor can be lifted out and the drum separates easily, that's fine. If not, we'll use another method to remove it. To separate the drum from the motor, I've made a special tool which will help me extract the motor. I'll tap it with a hammer. The motor has fallen down, and as you can see, the motor has come out towards the bottom. Now we've also removed the cover from the top and unscrewed all the side screws. As you can see, here are all the wires, and the light has already been disconnected by someone. Next, we'll remove the drum from the machine. There's another issue inside. You can see that the top side is open and broken. This can lead to water possibly reaching the motor, which is a risk. I'll also show you the taper position inside. The tool I used to tap the drum was to help extract the motor from this area. Now I'll also show you the motor. If you look closely, the rod is tapered. What happens is that the drum sits on top of this taper, and this helps keep the drum in a straight position. This taper is beneficial for stabilizing the drum. If we look at the manufacturing of this machine, I'm not impressed with the material used, but the technique applied here is quite impressive and, in my opinion, very effective. For example, this hole is typically sealed with a bush to prevent water from reaching the motor. However, here, they've built a raised wall about 2 inches high to keep water from entering the motor. Now, the other technique used is with the drum. You can see there's a plastic piece attached and tightened at the bottom, but this plastic is broken from here. The plastic should sit on the hole at the bottom, but since it's broken, it's not functioning properly. To explain this, I'll use an example. Imagine I have this pipe. When the drum sits inside, it creates a position like this. What happens is that when water is drained from the drum, it cannot go toward the pipe because the top is covered, creating a waterproof system. However, now that there's a hole, water leakage is possible. Now, we'll repair this part. The pipe that I had cut will be placed like this on top. This way, water cannot reach the motor. We'll attach it using silicone, applying the silicone, and then setting it in place. When it comes to the drum, we won't use silicone because silicone tends to come off after some time with usage. Instead, we'll use hot glue. After the hot glue dries, it becomes hard, reducing the chances of it coming off or becoming loose. This ensures a more durable seal. Now, as you can see, we have a new motor and we'll install it into the machine. But before installing the motor, we need to replace the indication light because the old one is broken. We can install the new light in 2 ways. One is that it turns on when the timer is on, and the other is when the main supply is turned on. It depends on how we want to install it. I will connect it with the timer, so the light will turn on when the timer is on. This timer is a series timer, meaning it has only 2 wires, which are attached in series, and this allows the motor to turn on. Since this light operates on 220 volts AC, we'll need to connect the neutral and phase wires to it. Without completing the line and neutral connections, the light won't turn on. Now, I've removed the old light and installed the new one. Now, we'll pass this wire through, and I'll explain which wires should be used. From these 2 wires, we can use either one. If we use the black wire, we can connect it to the main line and use the green wire, which is connected to the timer. If we want to use it directly, we can attach it to the main line, and then it will turn on with the main switch. However, since we are connecting it with the timer, we'll attach the wire connected to the timer in series with the light. The black wire will be connected to the main line, and the other wire will only be active when the timer and motor are running. This ensures the light operates correctly with the timer and motor functions. Now that the motor has been installed, we need to check the alignment of the drum and motor. As you can see, the motor is not properly centered. It is tilted to one side. To fix this, we need to adjust it so that the motor sits evenly in the center. To adjust the motor's position, I will use a technique to fix it. First, I will loosen the motor from one side and insert washers under it to lift it slightly. After making this adjustment, I will check again to see if the motor is centered. However, if it still isn't aligned properly, it means we need to adjust both sides. Now, I will place washers on both sides to ensure the motor is level. After making these adjustments, you can see that the motor is now centered correctly. Next, I will lift the cover and position the drum onto the shaft, securing it with bolts. Once everything is in place, I will reattach the cover to complete the assembly. Now, let's proceed with the wiring. First, we will connect the main electric supply to one of the wires. Once that connection is made, we'll join the blue wire as well. Next, we need to link one wire to the motor's common point. Here's how it will go. The black wire will be connected to the common terminal of the motor. For the capacitors, we have a 7.5 microfarad, 450 volt capacitor. One wire from the capacitor will be connected to the green wire coming from the timer, and the other wire will be connected to the motor. After making these connections, secure them with tape. Finally, for the starting point of the motor, we'll connect the remaining wire from the motor and tape it securely. With these connections completed, the wiring setup is finished. Now it's time to test the machine. I've already connected the electricity, and as soon as I turn on the timer, you can see the motor starts running. When I switch it off, the machine stops. Let me turn it on again, and you can see the machine is operational. Regarding the red cover machine, it has the same issue. We'll follow the same procedure used for the previous machine, replacing its motor. Once done, this machine will also be working perfectly. Lastly, I'll show you the timer light. You can see it's functioning correctly as well. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.